Hi, this is Dan Abbott, and I'm making this video for my AEDD 100 class in print reading at Southern Maine Community College. I apologize for my voice. I am out sick, which is why I'm making you this video. What we were going to cover was the use of scales, and by scales I mean physical scales that are used to measure distances on prints, and they're related to the actual scale on the print that's used to represent something too large to go on a sheet of paper. The different kinds of scales involve different disciplines. What we're looking at right here is a steel scale in metric, and this is the simplest of all the scales to deal with. If you take a look, the distance from here to here is 10 millimeters. At the top there's a series of divisions of a half millimeter. Down here is a full millimeter. Very straightforward. If you see below, we have a 30 seconds and a 64 scale, which are sometimes used in machine shops, although fractions aren't technically something that you can use for manufacturing anymore. It's been a long time since fractions were permitted. 32 means that there are 30 seconds means there are 32 divisions for every 1 inch. So the 1630 seconds is the equivalent of a half an inch. When you reduce it, 32/64 is the scale down below. And you'll note surprisingly, that the 1 inch lines right up a little less than halfway past the 25 millimeter mark, because there are 25.4 millimeters in 1 inch. Over here we have several different triangular scales. People tend to think that means they're architectural, and in the case of this little group on the upper left hand corner, they are architectural scales. All the architectural scales have one standard fractional scale, and that's measured in sixteenths. So over here we have 30 seconds, which is half the division of a 16th, and 64th, which is 1/4. So the scale can be used for just straight measuring. Then on the other 11 possible scales, because they start from one end and go to the right, or start from the right and go to the left, in this case we have a 3/16 scale, which simply means that the distance from where I'm pointing right here to here is 3/16 of an inch, and that every 3/16 of an inch represents 1 foot on the ground. So if you start with that 0 and go to that first segment or division, represents a 1 foot division, then you have the 2 feet, 4 feet, 6 feet, etc. Down here, 1/8 of an inch is the equivalent of a foot on the ground. A half inch is the equivalent of a foot on the ground. And in each of these cases, starting at 0 allows you to measure in feet. And then there's a little section that is the same actual length as the scale itself. In this case, 1/8 of an inch. In this case, 3/16. In this case, a half inch. And that division represents 1 foot, with individual divisions representing inches. Down here in the lower left-hand corner, it's a different type of scale. It's used in land and surveying. It's called an engineering scale. And in this case, it's measured in tenths, or 20th, or 30th, or 40th. I'm sorry, not 40th. It's 10 divisions, 20 divisions, 30 divisions per inch. And it is used in civil, because the scales used for drawings in civil are different than the scales used in architectural in the United States. So here's an architectural drawing, and it represents a full section elevation that was drawn at a 1/4 inch equals a foot scale. 1/4 inch equals a foot scale means that the house itself is 48 times larger than this drawing of the house. Here we have a scale imposed, or superimposed over the foundation, and it has a 1/4 at the end, which means a 1/4 of an inch on the drawing represents 1 foot. If you line the 0 up with the outside of the foundation wall and go all the way over to the other foundation wall, the 24 lines up, and that just shows you that that foundation is 24 feet wide, which is given down here. Now we have some details. The details are drawn larger, at a larger scale, so that they can show more detail than you could possibly show at a 1/4 of an inch equals a foot scale. So in this particular case, it's a 1 inch equals a foot scale, so the details are 4 times larger. 1 inch on the drawing represents a foot on the ground. So the example over here is an architectural scale that represents 1 inch equals a foot. And you notice that because that 1 inch can be divided into divisions representing inches, 3 inches, 6 inches, etc., in fact fractions of an inch, lining the 0 up at the top of that header, and that is a 2 by 8 header, 2x8 header is nominally 2 inches by 8 inches, but it's actually 1.5 inches by 7 1/4. If you were to measure it, starting from the 0, going down to the 6 and the 7, and then just to the next little mark, shows you that that header is 7 1/4 inches deep. I'm going to skip past this one. This is a slide showing you a piece of property. This was done by drawing by hand. I believe that was done by Ed Fitzgerald, yeah. Um, and it represents how you would use an an engineering scale to measure a piece of property. The scale given over here in the title block is 1 inch equals 40 feet. That just means 1 inch on the drawing represents 40 feet on the ground. And if you take 40 feet and multiply it times 12 inches per foot, you have 480, which just tells you that the property is 480 times larger than the drawing of it. If you put an engineering scale down on this piece of property and measure the distance from that property line out to the corner of the house, it's given there as 70 feet by using a 1 to 40 or 1 inch equals 40 foot scale. And this is actually really a 1 inch equals 40 unit scale, and it can be used for any division of 40. It could be 1 to 4, it could be 1 to 40, it could be 1 to 400. But the distance from here to here is 1 inch. That would be 40 feet. You keep going and you get to 6, and then this would be a 7 if it was labeled. That 7 represents 70 feet, and that 70 feet is the actual distance right there. And the other type of scale that we use is either the metric or the decimal inch scale. The decimal inch scale is actually a scale representing 50ths of an inch. 50th of an inch is 0.02 inches. And here's an example here of measuring distance across from here to here on a drawing that was done in metric. If you look over on this scale, this is a metric scale. So in this case, if you look at the distance from here to here, which represents 50 millimeters, you can measure that directly from the 0 to the 50. If you were to put a decimal inch scale on this to get a 1.97, and 1.97 is 50 divided by 25.4 millimeters per inch. So 50 millimeters divided by 25.4 millimeters per inch is 1.968 inches. And you'll notice that the scale in this case is a scale of 1 to 1. Now I'm going to switch over to the worksheet. So here's the worksheet that I'd like you to work on before the next class. In this worksheet, I simply want you to go and identify what the measurement would be for each one of these. So this first one is pretty straightforward. Starting at the 0 on a 1/16 of an inch fractional scale, what's the distance represented by the number 1? First it's 5, and then there's halfway between 5 and 6, so the answer to that would be 5.5. 5.5 is a decimal value though, and since this is a fractional scale, you would write the answer as 5 1/2 inches. If you take a look, let's take a look at number 2. 2 is going to be 4 inches. And then you look and there's 3 little marks past the 4. Since this is measured in 16ths, 3 little marks past the 4 means 3/16. So the answer to that, I'm using a little bit of a clunky way to do this, but 4 3/16 inch would be the answer on this one. We'll put a dash in there to make that a little clearer. So the ones that are beginning that are a little more difficult are the architectural ones. This is a 1.5 inch equals a foot scale. So 1.5 inches on a drawing represents 1 foot on the ground. And if we take number 6, you have to start by looking at the whole number represented on one end of that dimension. So starting over here, we've got a 0, a 1 then would go here, and a 2. That represents 2 feet. But it goes beyond the 2 feet. If you look over here, it goes beyond the 2 feet by 9, 10 inches. So that would be 2 feet, 10 inches, and there's no fraction because it lines right up. So number 6 would be 2 feet, 10 inches. And you need the foot mark. 2 feet, 10 inches would be an architectural representation. Take another look down here at the 3/8. There's a 3/8 scale, so if we look at the 9, for instance, number 9 starts over here on the 18, so that's 18 feet represented from represented by the distance from here to the 0. And then you go past the 0 by 11 inches. So the 18 feet would be represented, which is this number 9. So you have 18, a foot mark, a dash, and then 11 inches. Now let's go down and look at one of the engineering examples. So here's some engineering examples. And they require, you have to know before using the engineering scales what the actual scale is. Is it 1 to 50, 1 to 500? So we'll just take the 1 to 50 and the 1 to 500. I shouldn't say 1 to 50, I should say 1 inch equals 50 feet. So if a scale on a drawing is that 1 inch equals 50 feet, and you look at the measurement right here, the distance from 0 to that little mark right there would be 50 feet. So what we're doing in this case is, because that's the distance from here to there is 1 inch, so 1 inch represents 50 feet. So you can add a 0 to each one of these numbers. If we come over here to the 28, that's not going to be 28 feet, it's going to be 280 feet. So it'd just be 280, put a little foot mark in there. You can't really read that very well, can you? And that's a little bit better. Now, if 1 inch equals 500 feet, though, you look back over here, and 1 inch is from here to there, that's 1 inch. So that represents 50 feet. If the scale is 1 inch equals 500 feet, that now represents 500 feet. So you'd add 2 zeros. You come back over here to get the same number, 28, but then be 2 zeros afterwards. So the actual answer in that case would be 2800. 00 feet. So I just want you to fill out the correct measurement on each one of these. And the last page asks you to measure a bunch of lines and using various scales to do that. So we'll be going over this in class as well, but I want you to do as much of this as you can.